also increases. The direction of the bond polarity can be indicated with an arrow. The head of the arrow is at the negative or the more electronegative atom. Therefore, we can represent by arrow. I already told you about that one. For example, in the case of hydrogen chloride. So this arrow, okay, the head of the arrow is towards this chlorine, okay, but the tail of the arrow with small perpendicular line is towards the smaller electronegative atom participated in the bond formation. Therefore, we can easily represent by this arrow also. I already told you about this one. This one acquires partial negative because it is more electronegative atom when compared with that of hydrogen atom. This one has smaller electronegativity, therefore it acquires partially positive charge. All of them are polar covalent molecules. Hydrogen chloride, okay, hydrogen fluoride, water, ammonia, hydrogen sulfide, sulfur dioxide, methanol. This is oxygen containing compounds of hydrocarbon. It is also polar covalent molecule. Ethanol is also polar covalent molecule. So we can easily identify polar molecules by using their electronegativity value, and by using dipole moment we can also identify whether the molecule is polar or non-polar, and the dipole moment can be calculated by using this formula. Okay, so the SI unit of dipole moment is Coulomb meter, and the dipole moments are also often expressed in the non-SI unit dB, and 1 dB is all the time equal to 3.33564 times 10 to the power of minus 30 Coulomb meter. So by using dipole moment, we can also identify whether the molecule is polar or non-polar. So the dipole moment of polyatomic molecule, 3 or more atoms, depends on the geometry. The geometry, I will tell you about this, the geometry, how to identify the shape of molecules, okay, later. But now, all the time remember that the dipole moment of polyatomic molecule having 3 or more than 3 atoms depends on the geometry of the molecule. For example, look at these molecules, H2O. The molecular geometry of water is V shape, okay. You can write the Lewis structure for water molecule just like this. This is water molecule. But carbon dioxide, I already told you about this one. Carbon dioxide, this is the Lewis structure for carbon dioxide. The molecular shape of carbon dioxide is linear, but the shape of water molecule is V shape or angular shape or bent shape. This is polar, but this is non-polar. Why? Because I already told you about dipole moment, okay? Vectors have if they have the same magnitude, and if they are in opposite direction, they cancel out each other. Therefore, the dipole moment for this molecule is 0. But the dipole moment for water molecule is greater than 0. If molecules have dipole moment greater than 0, that molecules are polar covalent molecules. If the bond moments are equal in magnitude but opposite in direction, then they will cancel each other, and the resultant dipole moment will be 0, provided that the vector sum of the bond moments is 0, then the molecule is non-polar molecule. For example, dipole moment of carbon dioxide is 0, so it is non-polar molecule. The dipole moment for sulfur dioxide, the shape of this inorganic compound, sulfur dioxide, is V shape, bent shape, and its dipole moment is greater than 0. The value is 1.62, therefore this molecule is polar molecule. Water, its dipole moment is greater than 0. It is equal to 1.85, so it is polar molecule. CH3Cl, this also polar molecule. Its dipole moment is greater than 0, 1.92. CH2Cl2, its dipole moment is 1.59. CHCl3, its dipole moment is 1.02. But carbon tetrachloride has 0 dipole moment, so it is non-polar molecule. But others are, except carbon dioxide and carbon tetrachloride, other molecules are polar molecules. So try to compare the dipole moments of this molecule. Okay, here we have only 1 chlorine atom, but here we have 2 chlorine atoms. Here we have 3 chlorine atoms. When the chlorine atoms increases, their dipole moment decreases. But carbon tetrachloride has 0 dipole moment. Okay, if all of them are chlorine atoms, therefore its dipole moment is equal to 0. So try to differentiate the dipole moments of these molecules. I already told you about this one. So the vector, these vectors, okay, cancel each other, and the dipole moment for this carbon dioxide is 0, but the dipole moment for sulfur dioxide is greater than 0. The shape of this molecule is bent shape. This one, okay, toward this chlorine, but from carbon and hydrogen, carbon has high electronegativity, so the vector is toward this carbon. The head of the vector is toward this carbon, the tail is toward this hydrogen. Therefore, we must add these vectors together, and the net dipole moment is this one, so it has high dipole moment. Therefore, this is polar covalent molecule. Water, this dipole moment is 1.85, so the vector is toward these oxygen atoms, so we add them together. After that, the net dipole moment is higher, so it is polar molecule. This is carbon tetrachloride, no net dipole moment, so it is non-polar molecule. Okay, so let us just answer some questions, and some of these questions are from university entrance exam questions. And the question number 1 says that which of the following is a polar molecule? I already told you that iodine is non-polar molecule because the bond between these two iodine atoms is non-polar bond. This molecule is non-polar molecule. The question is which one is polar molecule? Carbon dioxide is also non-polar molecule. We are talking about molecule. We are not talking about the bond. Therefore, the molecule is non-polar molecule. I already told you about this one. Carbon tetrachloride is also non-polar molecule because the vectors, okay, cancel each other, and the dipole moment for this carbon tetrachloride is equal to 0, so the molecule is non-polar molecule. But hydrogen sulfide is polar molecule, okay? Its dipole moment is greater than 0, and the shape of this molecule is V shape. Therefore, this is polar molecule, and the correct answer for question number 1 is D. Question number 2. In a molecule is the most electronegative atom, so it attracts electrons more strongly because of its high electronegativity and acquires partial negative charge. I already told you about this one, so C is the correct answer. Question number 3. Which of the following bonds is the most polar? So easily just calculate the electronegativity difference between these two atoms. Fluorine is the most electronegative atom. Its electronegativity value is 4, but the electronegativity value for hydrogen is 2.1. 4 minus 2.1, this is equal to 1.9. So this bond is highly polar when compared with others. Okay, calculate the electronegativity difference of each of these bonds, and then you can compare that difference with all of them. After that, you can easily identify which one is more polar bond. So A is the correct answer. Question number 4. In a non-polar covalent bond, electrons are equally shared if it is non-polar. If the bond is polar, electrons are unequally shared. So the correct answer for question number 4 is B, shared equally between atoms if the bond is non-polar covalent bond. So B is the correct answer. Question number 5. Why is carbon tetrachloride, CCl4, a non-polar molecule, even though it contains 4 polar carbon to chlorine bonds? I already told you about this one. Okay, so the correct answer for this question is B, because the polar bonds cancel in opposite direction, but they have the same magnitude. So B is the correct answer for question number 5. Okay, question number 6. Which molecule contains non-polar bond? The bond between hydrogen and chlorine. This is polar bond because the electronegativity value difference between these two atoms. Chlorine has 3.0 electronegativity value, and the electronegativity value of hydrogen is 2.1. So 3 minus 2.1 is equal to 0.9. It is greater than 0.5, so the bond is polar. But here we have the same atoms. So the electronegativity of fluorine atom is 4. The electronegativity of another fluorine atom is also equal to 4. 4 minus 4 equal to 0. Therefore, the bond is non-polar. So B is the correct answer. Among the following molecules with highest dipole moment, here we have only 1 chlorine atom, but here 3 chlorine atoms. The vector of 1 chlorine atom cancels the vector of another chlorine atom because they are in opposite direction, but they have the same magnitude. Therefore, it decreases the dipole moment. So the dipole moment of this is greater when compared with other. What's the dipole moment for carbon tetrachloride? It is equal to 0. So C is the correct answer for this question. Question number 8. Which one of the following molecules is a non-polar molecule? This is polar molecule. Ammonia is also polar molecule. Carbon monoxide also polar molecule. But boron trifluoride is non-polar molecule because the shape of this boron trifluoride is trigonal planar. So the vectors cancel out each other and the dipole moment of this molecule is equal to 0. Because of this reason, it is a non-polar molecule. So D is the correct answer. So this is all about polarity in covalent molecules. See you next time. Until then, bye-bye.